All right, everyone, welcome back to the channel. Now, today it's going to be a quick video, it's going to be a short one, but today we want to look at a few Docker commands. We want to get familiar with some Docker commands, and we also want to see how we can debug, all right, our containers using the exec, keyword. So in Docker, you have what you call the dockerexec keyword, which basically is something like Docker, all right, exec. Okay, now where you use this particular command is when you have a running container that you want to log into. You can think about that like, you have an EC2 instance that you have deployed on AWS, and then you want to SSH into your instance, right? To basically manage it, to maybe check certain things. If perhaps maybe you bootstrapped your instance with the user data, you want to check if the user data inserted correctly. You want to check if there's an error, perhaps if the user data is not giving you what you expect. So you want to log into your instance and basically verify if the installation went, very well, or there's something that actually went wrong that you need to correct. Okay, so in the same way, you also have Docker exec command, which basically is to help to manage your containers. Now, the Docker exec command can only be used with a running container, which means if your container is not running, you cannot use the Docker exec command. Okay, now you can look at that also, like if you have an EC2 instance that you have stopped, there's no way you can SSH into that instance. The only way to SSH into your instance is to basically make sure that your instance is running. If your instance is running, then you can SSH into it and perform whatever management that you want to perform. Okay, so in the same vein, you can only do Docker exec on a running container. If the container is in the stop state or it has exited, then you cannot run the Docker exec command. Is that okay? So we need to bear that, all right, in mind. So if you want to do Docker exec, you have to make sure that the container is running, and then you are able to, all right, log in into that container and then perform whatever operation it is that you want to perform. Is that all right? So I thought to mention that. Now, another thing also that I want us to look at, like I said, we want to look at a few Docker commands, right? So there is the Docker run, which we have looked at a couple of times. There's Docker images, there's Docker, all right, network. I mean, a whole lot of things, okay? There's what you call the Docker system, all right? And I mean, too many Docker commands, okay? But of course, we have the help that we can use to, check a list of commands that we can run. For example, I can come and say docker -help, okay, and that would show me a list of commands that I can actually run and some other, options and arguments that can be passed in to the Docker command. So there's Docker run, there's Docker exec, there's Docker ps, Docker build, and a whole lot of, all right, stuff that you can see right here. Now, again, another thing that I would also like to share with us is that now there are some commands that are, kind of similar, right? And there are commands that, you can run them using different methods, okay? For example, if you do Docker, all right, images, it basically lists out the images that you have running on your system, okay? And another way, if you do Docker image, all right, ls, it basically gives you the same thing. So Docker images will list out the images that you have on the Docker, all right, platform or engine that you have on your system. Docker image ls will also list out the same thing, all right, for you. So you have to know where to use which one. So Docker images, Docker ls, and all of that. Now, if you do Docker, all right, images, you cannot do images ls, right? That does not make any sense, right? But then you can do Docker images, and then you can also look for help in that regard to basically see what are the options that can go with this particular, all right, image, all right, this command rather. Now, if you look at what you have here, it shows you the aliases, okay? So the Docker images also has this alias, which is Docker image ls, Docker image list, and Docker, all right, image. So which means if I do Docker images, I'm going to get the same result as if I do Docker image ls. If I do Docker image list, it's also going to give me the same, all right, result at the end of the day, right? Now, there's also what you call the Docker system, all right? And then you can do L for that as well. and check the things that you can do with that. So the Docker system is basically a command that can help you to manage your Docker system in terms of checking the disk usage, in terms of checking the information about your Docker engine and your Docker system that is running. And also, you can also do Docker system prune to basically, delete all the containers that are not running, that are idle, volumes that are anonymous. I mean, we're going to get into volumes later. All right. I mean, anonymous volumes and things that you really are not using. Okay. So if you have a container that is idle, that is not attached to any image, you can use Docker system prune to basically remove all of those kinds of, containers. And then if you have images that are also idle, that are not, connected to any container. So which means that image, any containers that may derive from it, you can also use Docker system prune to basically remove that, all right, from your, Docker system. Now, the importance of that is that, it saves you a lot of space. So if there are containers that are just, not running anything, it's not attached to any image, it's just dangling, basically, right? You can use the Docker system prune to basically prune, all right, those kind of resources that are not in use. Okay, but of course, you want to use the Docker prune, very cautiously, because it can delete, everything that is not running, and there are some images that are containers that maybe you stopped it, all right, and you still want to run them again. You have to be sure that, you're using that command cautiously, not in a production environment, but maybe in a development environment. You can try the Docker system prune and all of that. But of course, if you do Docker system, okay, and then you can do info, that will show you information about, all right, your Docker system that you have running on this particular machine. So on my own machine, I have the Docker version 27.2.0. All right, it's a Docker desktop Linux, and these are the plugins that have been installed with it. So there's the BuildX. We're going to get into that right in later video. There's Compose, Debug, Desktop, Dev, Extensions, Feedback, Init, all right, SBUM, and of course you have the Docker Scout, which is a tool like Trivy, which you can use to scan Docker images for vulnerabilities and things like that. And then it shows you the information about the Docker server. So I have just one container that I have within my Docker server. I don't have any running container. I don't have any post. I have one stopped container. I have one image. And then, of course, it shows me the version, the storage type, and a whole lot of information right here. Okay. Now, let's get into the Docker exec that I talked about earlier. These are just a few Docker commands that I wanted to show us, okay? We're still going to get into Docker volumes. We're going to get into Docker network, how to create a Docker network, how to run maybe 2 applications on the same network, how to create a volume to ensure that your data is persisted, particularly when you're running, database applications and things like that. You want to ensure that your database records, your data is actually persisted, which means if the container that is running your database should, go out of service or exit, all right, the volume where the data is being persisted can be mounted on another container, all right, and then your data can be retrieved and the application can still be running using the previous, all right, data. So we're going to get into all of that, right? Like I always say, knowledge is progressive, okay? So we have to build gradually until we get to, all right, mastery, okay? So we can't jump certain processes. So that's why I take my time to explain things, all right, to us, okay? So let's take a look at the Docker exec and let's see, all right, how to use that. So what I'm going to do is I'm going to build my image again because, I deleted it actually, so I don't have it. So I'm going to do cd into node.js, all right, and then I'm going to say docker build -t, all right, and the name I want to give to this is just node, all right, bookworm. So so this is the bookworm. So the version we're using is actually the slim version, so we can just leave that, and then I'll say dot to specify that my Docker file is in this current working directory. All right, so now you can see that the building, all right, took a very little amount of time. And the reason is because if you look at what you have, it says cached, right? And that is because I have built this image, okay, on this particular system a couple of times. So there are certain layers that have been cached already. So Docker will not attempt to, download those new image layers rather, right? It will just basically dip into its own cache or cache and then use that to, build the application, all right, for me. And one of the reasons why it does that is because if you look at what I have here, the server.js has actually not changed, which means I've not updated the server.js. So when Docker looks at it, it looks at it like this file is actually still the same as what I used previously. So there's no change at all. So it just basically used what it has cached and then used that to build or rather image. And that's why you will look at it here and say, it was quite fast. Right, it didn't take as much time as we would expect, all right, it to take. Now, apart from the fact that the image we're building is light, all right, and then we're not building any complex application just yet. But of course, if you look at the cache that you have here, it basically tells you that when you're building Docker images, Docker has what you call cache, all right, that it can leverage to speed up your build at the end of the day, particularly if anything has not changed from the last build. Okay, Docker will basically just leverage the cache to, speed up your build, all right, process. So that's why you can see that build was actually very fast. Okay. Now the image has been built, so I can come here and say Docker run. Now, another thing that I'd like to show us here, another command I'd like to show us here is Docker run -rm. So what is the meaning of this, all right, rm, right? Why do we need it? Okay, so Docker run -rm -d-p. So my application runs on port 8080. So I'm just going to say 8080, all right, column 8080, just anything. Now, what is the purpose of the rm right here? Now, Docker run -rm basically will ensure that the moment I stop this container, right, the container is deleted immediately. Okay, so that is, I just want to run this, all right, container, all right, to just do something, very quickly, right? And the moment I do Docker stop the container ID or the container name, then what is going to happen is that it is not only going to stop the container, but because I have passed in a flag, all right, -rm, it is going to remove that container as well. All right, so that is what this rm right here is doing. So which means start the container, but the moment the container is stopped, then remove that container, all right, from Docker, all right, manage. So that means that container will no longer exist, all right, exit again, right? It's just going to be deleted automatically. So Docker run -rm basically means you want to run this container for a short time. The moment the container is stopped, the container is also deleted immediately. Is that okay? All right. So I'm going to call this, so let's call this name. So we're just going to call it notebook, all right, bookworm. And then the name of the image that we built is actually node-bookworm, okay? So that's going to be node-bookworm, all right, column latest, remember. So let's run that. Now, if I do Docker, PS, I can see that I have this one container already running. Okay, and of course, if I go here to my browser and I do localhost 3000, I think I used 8080, right? So if I do 8080 right here, I can see that my application is all right and running. Now, how do we use the Docker, all right, exec? So here we say Docker exec, right, -it, which means I want to run it in an interactive mode, okay? Because I want to be able to interact with my container, like I'm interacting with my Linux server. All right. That is what the exec basically will help us to achieve, right? So it's like you're SSH into your container. Okay, so you're SSHing in an interactive mode. Remember, when you want to SSH into your Linux machine as well, you also do SSH-I, which is basically to specify that I want to be able to interact, all right, with my server. Okay, and then the T there basically means, to make a terminal, a TTY section, all right, available. Okay, where I can run commands and basically just, whatever it is that I want to do within that environment, I should be able to do it, and of course get a feedback from my server, all right, as well. So that is what IT here basically will help us to do. So the next thing you will pass in here is the container ID or the name of your container. So the name of my container is node, bookworm. And I mean, you can see the reason why it is good to name your container. So when you're running a container, it is very important to give them a name so that even if you do not remember the container ID, you can actually just use the name instead of the ID, which is easier to remember, all right, in most cases. So now I can use two things. So I can either come here and say, all right, bash, or I can say sh. Now, depending on the version, all right, of the base image that I am using. Okay, so let's press enter. Now, if I do sh, you can see here that it gives me a dollar prompt. Now, that dollar prompt basically means I am inside of my container. So if I do pwd, I may not see anything. It just shows me the /, which means I am in the root directory, all right, of my container, or the root path, all right, of my container. Now, if I do ls, I can see all of the Linux, all right, directory that are available in the root path. So you can see the bin, the boot, the dev, the etc, the home directory, and a whole lot of other things right here. So with this now, I am actually inside of the container, and whatever debugging, whatever troubleshooting I want to do here, I can actually carry it out right here. Now, I can also do something like cat, all right, etc/ all right, os release. Okay. Oops, sorry. I think it's OS. All right. Now you can see that the up arrow is not working here, right? Because the up arrow is to, recall the previous command, right? And if you look at it here, it's not actually working. So that's another thing that you need to pay attention to. So let's type that again. etc/os-release. Okay, so it's release, not releases, right? Now, if you look at this, so this is bookworm. So this is a bookworm slim. And if you look at what you have here, the bookworm slim is actually built on top of the Debian Linux 12, all right, operating system. So we can say the bookworm slim was derived from the Debian, all right, Linux operating system, as we can see from here. And if you look at the support URL, it points you, all right, to the Debian, all right, website. Okay, so that's one thing that we can also do. Now, if you look also into the src folder, all right, we can see that our server.js was actually copied into that folder. That means if I do cat, all right, src, okay, /server.js, I can actually see all my files right here. So if I look at it with what I have here, I can see that it's actually the same thing. So if you look at what you have here, the first line says file hello world node server.js. You can see that right here, all right, and then you can see all the other things right here. So you can see that it actually copied the file, okay, from your system, all right, into the image, and then when you run that image as a container, the file was basically made available, all right, inside of the container, all right, as well. Okay, I mean, after all, a container is a running image. Okay, so everything that you've copied into that image will automatically be available in the container when the container actually is running. Is that okay? So that is basically how you can use the Docker exec to log into your container and check things, verify things, all right, play around within your container, more like I said, more like your SSH chain, all right, into your container. That is exactly what it is. Now, earlier, I talked about the Docker RM, right? So let's try to stop the container and let's see what we're going to get. So I'm going to say Docker stop. Okay, so I'm going to use the name of my container, so which is bookworm, all right? And then I'm going to stop that, right? So I'm stopping that container. So let's see what will happen. Now, normally, when you stop a container and then you do Docker ps-a, you should still, all right, see that container, all right, as a stopped container. But in this case, based on how we ran this particular image, we specify the -rm. So which means it's going to stop. And then once the container stops, it's going to delete. So let's take a look at Docker ps-a to see if the container is still there. So if you look at what you have, I'm only seeing my Minikube container that I've stopped right here. So the Docker, all right, the node bookworm container that I actually started has been removed automatically. So when I stopped it, it didn't just stop the container alone, it also removed that container. Okay, so basically that is a use case for short-lived containers. So when you want to run a container just for a short period of time, and then the moment you stop the container, you want it to be removed also, right? That's the command to put in. Okay, so thank you. I'll see you on the next one.